Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized pieces. Today, we're playing detective. Imagine you have a team of super intelligent AIs working together to solve a complex problem, like planning a cross-country road trip.
They have to calculate the route, find hotels, estimate fuel costs, book restaurants, the works. But at the end, the final plan has you driving into the Grand Canyon. Something has clearly gone very, very wrong. The question is, who's to blame? Was it the route planner AI, the budget AI, or the booking AI? And when did they make the critical mistake?
That's exactly the problem tackled in a new paper called Who Broke the System? Failure Localization in LLM-Based Multi-Agent Systems. It's all about pinpointing the source of errors when a team of AIs messes up.
First, let's quickly define what a multi-agent system is. We're not talking about one single AI like ChatGPT. Instead, think of a team of specialized AIs, or agents, all powered by large language models. One might be a coding expert, another a data analyst, and a third a writer. They collaborate, pass information back and forth, and work together on tasks that would be too complex for a single agent.
These systems are incredibly powerful. They're being used for everything from software engineering to scientific discovery. But, as the paper points out, their complexity is also their weakness. When a project fails, finding the root cause is a nightmare.
It's because a tiny error made by one agent early on can ripple through the entire system. The data analyst might misinterpret one number in a giant spreadsheet. The other agents take that bad number and run with it, building flawless logic on a faulty foundation. By the time you get the wrong answer at the end, the original mistake is buried under dozens of perfectly correct steps.
It's like a detective trying to solve a case where the crime happened on Monday, but the body wasn't discovered until Friday. The trail is cold, and everyone's actions are tangled together. How do you find that one single moment where everything went off the rails?
Previous methods for doing this weren't great. Some tried a what-if approach, replaying the scenario and changing one agent's action to see if it fixed the problem. But in these complex systems, changing one thing can alter everything that comes after it, making it hard to get a consistent answer.
Other methods used a template-based approach, trying to match the failure to a list of known error types. But AIs are constantly finding new and creative ways to be wrong, so you can't predict every possible mistake.
So, the researchers behind this paper proposed a new framework, and they gave it the perfect name, Agent Locate.
Agent Locate treats failure detection not as a single decision, but as a process of investigation, verification, and learning. It's structured like an internal affairs division for AIs, with two main roles, the judge and the evaluators.
It starts with the judge. The judge is another powerful LLM that acts as the lead detective. It gets the full case file, the entire log of every action and message exchanged between the agents on the failed task. Its job is to review all the evidence and make an initial hypothesis.
So the judge might say, okay, after reviewing all 10 steps, I think the problem started at step 6, when the validation expert agent mistakenly assumed a value instead of waiting for the real data. It pinpoints a who and a when.
But Agent Locate doesn't just trust the judge's gut instinct. That initial hypothesis is then sent to a review board of other AIs called the evaluators. This is the really clever part. These evaluators are independent. They look at the same case file and the judge's hypothesis, but their job is to come to their own conclusion.
And they're not all the same. The researchers give them different personalities or instructions. One evaluator might be told to be very concise. Another is told to focus only on citing specific evidence from the logs. A third might be given a more general base-level prompt. It's like getting a second, third, and fourth opinion from different specialists.
Exactly. One might be a stickler for rules, another might be more of a big-picture thinker. This diversity prevents the group from falling into the same trap or having the same blind spot as the original judge. Each evaluator comes back with their own verdict, a rationale for their decision, and a confidence score.
Then, Agent Locate aggregates these opinions. It runs a confidence-weighted vote. If two evaluators are extremely confident that the error was at step 6 and one is only sort of sure it was at step 4, the system gives more weight to the confident majority. This produces a much more robust and reliable final answer.
And here is the killer feature. The system learns. The final verified result from the evaluators is used as a training example to fine-tune the original judge. The judge is essentially told, here's a case you worked on, here was your initial guess, and here's what the review board concluded was the right answer. Learn from it.
So the judge gets smarter over time. It gets better at spotting subtle errors and understanding complex failure patterns. It's a feedback loop that constantly improves the system's ability to diagnose itself.
The results are pretty impressive. The researchers tested Agent Locate on 2 different benchmarks with all sorts of different tasks and agents. Across the board, Agent Locate was significantly better at identifying both the responsible agent and the exact step where the decisive error occurred. It also did all of this while being computationally efficient. It didn't take a huge amount of time or money to run, which is a huge deal for real-world applications.
So why does this matter? Well, if we're going to rely on teams of AIs to do important work, like debugging code, aiding in medical research, or managing complex logistics, we absolutely need to be able to trust them. And when they fail, we need a reliable way to figure out why.
It's a fundamental part of building dependable and transparent AI. You can't fix a problem if you don't know what's broken. This paper doesn't just ask who broke the system, it builds a clever, self-improving system to find the answer. It's less of a blame game and more of a robust debugging tool, which is exactly what the field needs to move forward.